The first concept is the limit of a function, right? What is the limit of a function? So in simple words, when x approaches a certain value, what does the function f of x approach? So if there is a function f of x, and I say that x approaches a number 3. If x approaches 3, what does the function f of x approach? That is the basic question that we are trying to answer, and that's what a limit of a function is. So I'll give you a couple of examples. So look at this example over here. So you have x on the left-hand side of this table, and the function that's given is x squared. All right. I want to find out what f of x approaches if x approaches 2. So on the left, I have numbers starting from 0, increasing and approaching 2, right? So I got 0, 1, 1.5, 1.75, and so on. And it approaches 2, and I have gone up to 1.999. So the first thing you notice is that I don't have 2 in the table, right? So the word approach is important. I did not say what happens to f of x when x reaches 2, or if x is equal to 2. So the key word here is approach. So I'm approaching 2 on the left-hand side. And as I'm approaching 2 on the left-hand side, I note down what the value of x squared is. So as you can see, these are the different values of x squared. And just by looking at this table, you can see that as x approaches 2, f of x gets closer and closer to 4, right? Okay, so as x approaches 2, in this case, f of x, which is x squared, approaches 4. Let's look at another example. So I have x here, and I have x plus 2 here. So again, I put in several values for x, starting from 0, approaching 2, and I see what happens to x plus 2. You can see that x plus 2 approaches 4, gets closer and closer to 4. So as x approaches 2, f of x approaches 4, right? So, so this is one way of answering this question. Now, another way of answering this question is by using the approach of graphs. So we're trying to figure out what the graphical meaning of this question is, finding the limit is. So look at this graph. So here f of x is x squared. So as you know, it's a parabola, and this is how it looks like. So I want to find out what happens when x approaches 2. I have marked here the point 2, 4, right? So from this graph, it's easy to see that as x approaches 2, f of x approaches 4. So the point on the graph would go like this. So as x approaches 2, f of x will approach 4. The same thing with this graph as well, right? So here f of x is x plus 2. So which is a straight line, and I've drawn the graph here. I've marked the point 2, 4 over here. Again, as x approaches 2, f of x approaches 4, right? So the point on the graph would go like this. Again, I want to emphasize the fact that we are actually not going to reach 2. The whole point is just to find out, as this point goes along the line towards 2, what happens to f of x? It goes towards 4. So that's the whole point. All right. Now that we understand this, we understand the kind of the conceptual meaning of the limit. Let's actually define what it is. So this is what a limit is. When x approaches a certain value, the value that the function f of x approaches is called the limit of the function. All right. So in this case, as x approaches 2, we know f of x approaches 4. So we would say that the limit of f of x as x approaches 2 is 4. Okay. So here in this example here, I've written this in a general form, and this is how you would write it in a concise mathematical form rather than writing it in words as a long sentence. You would write this as limit LIM, and underneath you would say as x approaches c, which is a certain value. So the limit as x approaches c of the function f of x is equal to L. Okay, so you would read this as the limit of f of x as x approaches c is L. Okay, so again, going back to what I said, where I said that x doesn't really equal 2 and f of x doesn't really equal 4, but the limit is equal to L. Okay, because the limit is actually the value that f of x approaches. So if it approaches L, then the limit is equal to L. All right. Now let's look at this. Consider this function here. F of x equal to x squared minus 2 over x minus 2. All right. Consider this function. And I want to find out the limit of this function as x approaches 2. Right? Let's see what we can do here. If it's a simple function like this, it's easy for us to figure out, because as x approaches 2, we're going to just substitute 2 for x, right? You're going to do 2 plus 2, and we know that f of x is going to approach 4. Can we do the same thing here? As x approaches 2, is the limit simply substituting 2 for x? Because if you substitute 2 for x, what do you get, right? I mean, if you find out the value of f of x at x equal to 2, you are getting 0 for the numerator and 0 for the denominator, right? So it doesn't work. 0 over 0 is undefined. So the limit of this function, as you can see, is not as simple as we thought it would be. It's not as simple as just plugging in the number, right? So how do we figure that out? So let's try to see if we can figure it out by using graphs, okay, and also by using this table. So let's do the same thing we did for the previous two functions. So we have x over here. So we have this new function x squared minus 2 over x minus 2 here, and I'm, taking numbers from 0 all the way to 2 as x approaches 2, and I'm going to figure out what this function is. Now, as I write values for this function, you can see that the function does really approach 4, right? So even though I cannot plug in 2 for this function, because if I plug in 2, the denominator becomes 0, the numerator becomes 0 and doesn't work, I can't evaluate the function. But even though I can evaluate the function, you can see that the limit of this function does exist, because I can clearly see that it does approach 4.